applications with quadratics. So the same strategy that we introduced in solving modeling types in Chapter 1 and Chapter 2 applies to quadratics. First thing you should always do is read the problem through carefully, understand what you're asked to find, understand what you're given, assign your variables, draw a picture if you need to, set up the equation. And this time our equations will be quadratic, right? And we use the equations. Typically with quadratics, we're looking for either where we get max and minimum values or where things are increasing or decreasing. Right? So that's why finding the vertex is important. Right? We went over a bunch of different ways to do that. And so these applications are going to focus on finding that vertex where we're going to get a minimum value and a maximum value. But usually finding the vertex is the easy part. For students, it's the setup that's the hard part. All right, setting it up, the strategy to get to the quadratic where I can then find my vertex. And so we're going to practice a few different cases. So the first case is going to be a geometry type. Alright, so using a quadratic to find a max and min value, finding the quadratic first, and we'll do more with this in the next few sections that to come to. We're just going to kind of introduce it a little bit here, a couple examples, geometric example, and then the next example is a physics example, and then we'll look at some examples where we give you the quadratic. Alright, so these are though finding it. Alright, so I've got a rancher that wants to fence a rectangular area for cattle. Alright, and he's going to use a part of the river, because they're going to use the river as a boundary, as one side, alright, where the cattle can go drink and they're not going to cross the river. Suppose it's a big river and the cows won't try to cross it because it's too big. Alright, so the rancher has 3,600 feet of fence to use, so he's got that amount of fence, and so he wants to use that amount of fence, and he wants to find the dimensions that he needs to make his rectangle. So what does he need to make the width of the rectangle and the height of the rectangle in order to have the biggest possible area, the maximum possible area for his cattle? Alright, so we've got sort of a flat, so let's assume this is the river side. Alright, river side, which means we don't need a fence on that side. Which means we're going to have a fence, rectangular fence here. Alright, there's my fence. The red part represents the fence. We have a total of 3,600 feet of fence, right? That's the red part. This red area, when I add it up, should add up to 3,600. Right, but there are two parts to the rectangle. There's these height or width parts, if you want to think about them that way. And then there's this one side here that's the length. And those are going to be my unknowns. I need to figure out what those values are. What do I want my heights to be, my widths to be? What do I want my lengths to be? And so I'm going to let X represent the width and Y represent the length. Alright, so X represents the width of the rectangle in feet. Y represents the length. And I only have one length in feet. When I take the X values plus the Y values, they've got a total, so there's my first equation. When I take one X plus another X, right, there are two X values, plus the Y, so that would be all of my fencing, right? I have these two sides of fencing and that side of fencing. They have to add up to 3,600 feet of fence. And if I simplify that, it means 2X plus Y have to be 3,600 feet. Alright, so that's just based on the information and the limitation of the amount of fence I have. Alright, I haven't got to what I want to maximize yet. We want to maximize the area, right? We want to maximize area. Alright, well, what is area?